Hey everyone, and welcome to The Explainer. You know that feeling when you're coding and you think, wait a minute, I've solved this exact problem before. It's like a kind of design déjà vu. Well, today, we're diving into the brilliant concept that was literally designed to cure that feeling. Software design patterns. We're going to see how these blueprints for code can make everything we build way smarter and way more elegant.
Okay, so to really wrap our heads around what design patterns are all about, we're actually going to start somewhere you might not expect. We're not looking at a computer screen, we're looking at a construction site.
Just think about it for a sec. When an architect sits down to design a house, they don't reinvent the window, right? Or the door. Of course not. They use these established, proven patterns that everybody already gets. And believe it or not, that very idea, that's what sparked the whole movement to bring patterns into software. And that is the big connection. You know, just like architecture has these classic recurring challenges like how do we support this roof or how do we let in more light? Well, software development has its own set of common, nagging problems. Design patterns are basically the catalog of proven, battle-tested solutions to those very problems. Now, this is absolutely crucial to understand. A pattern is not just a chunk of code you can copy and paste. No. It's much more like a strategic blueprint. It's a proven approach that you then adapt to solve your specific problem.
So every really useful pattern breaks down into these four essential parts. First, you've got the name. This gives us a handle, a shared vocabulary to talk about it. Then you've got the problem, which tells you exactly when to apply the pattern. The solution obviously describes how to do it, the elements, the relationships, but I think the most important part is the last one, the consequences. This is all about the results and the trade-offs, and that's what helps you make genuinely smart design decisions instead of just, blindly applying some formula.
All right, so now we know what a pattern is. Let's actually see some in action, yeah? We're going to start with the first major category, creational patterns. And as the name suggests, these are all about one fundamental challenge. How do you create objects without tying your entire system into knots?
So let's look at a classic problem. This one's straight out of the book's big case study. Imagine you're building an app, and you want it to look and feel totally native on both a Mac and a Windows machine. You know how it is. The buttons look different, the scroll bars are different, the menus are different, the whole shebang. So how do you create the right set of UI elements without just filling your code with a million messy if-then statements?
Well, the answer is this absolutely brilliant pattern called the abstract factory. Instead of your code asking for a specific kind of button, like a Mac button, it just goes to a factory object and says, hey, create a button for me. All you have to do is tell the app which factory to use right at the beginning. Are we using the Mac factory today or the Windows factory? And then that factory takes care of creating the entire family of widgets that all match. The best part? Your main application code stays totally clean and completely clueless about which look and feel it's even running.
Okay, so creational patterns help us make objects. But what about organizing them once we have them? That, my friends, is where structural patterns come in. These are all about how we can assemble objects and classes into bigger structures. Structures that are really powerful, but also super flexible.
Let's take another common headache. Say you're building a graphics editor. You've got your basic objects, right? A single line, a text box. But then you also have complex objects, like a picture that's actually made up of a whole bunch of lines and text boxes. Wouldn't it be great if you could move or draw that entire picture just as easily as you could move a single tiny line?
Well, that is exactly the job of the composite pattern. What it does is organize your objects into a tree-like structure. So you have your individual objects, the leaves of the tree, and then you have your groups of objects which are like the branches. And the magic is they all share a common interface. This means your code can just tell any object, hey, draw yourself. And it doesn't care if it's talking to a single line or a super complex picture made up of hundreds of different things. It just works.
Okay, so we've got patterns for creating objects and for structuring them. What's left? Well, the final piece of the puzzle is all about managing how these objects talk to each other. And for that, we enter the world of behavioral patterns. These are all about communication, responsibility, and collaboration.
Think about this classic behavioral problem. You've got a spreadsheet full of data, and you've got a nice pie chart that's visualizing it. When you change a number in that spreadsheet, the chart has to update instantly, right? But here's the catch. You really don't want the spreadsheet code to be hardwired to know about the pie chart. I mean, what if you want to add a bar chart later, or a line graph?
This is where the observer pattern comes in, and it solves this so elegantly. The spreadsheet becomes the subject, and any chart, or anything else really, can be an observer. So when the spreadsheet data changes, it doesn't know who's listening, and it doesn't care. It just shouts out a notification like, hey everyone, I've changed.
And the pie chart, which is subscribed to these updates, hears that message and goes, okay, I need to redraw myself. It's that simple.
And this, right here, brings us to the secret sauce behind so many of these amazing patterns. It's a core principle of good design. Programmed to an interface, not an implementation. So, what on earth does that mean? It means the spreadsheet doesn't know it's talking to a pie chart class specifically. It just knows it's talking to something that is a generic observer. Any object that promises to act like an observer can listen in. And that's what makes the whole design so incredibly flexible and reusable.
Okay, so we've seen a few really cool examples. Let's zoom out a bit now. What's the real power here? What's the big deal about thinking in patterns? I love this quote from the book because every single developer knows this feeling, that nagging sense that you're just reinventing the wheel. Well, patterns are the answer. They are the collected wisdom of our entire field, designed specifically to stop us from solving the same problems again and again and again.
When it comes down to it, using a design pattern means you are standing on the shoulders of giants. You're literally tapping into the experience of countless expert designers who have already faced and solved the exact same problem you're looking at right now. And this is why this stuff matters so much. First, patterns create a common vocabulary. It's so much faster and clearer to say, let's use an observer here, than to spend 10 minutes describing the whole mechanism from scratch. They help you avoid that design déjà vu, and they make your systems way more flexible and reusable. And maybe best of all, they give novices a roadmap, a way to start designing like experts right from the get-go.
So I want to leave you with a final thought here. This whole idea of identifying a recurring problem and giving its solution a name, it's not just for software. Not at all. It applies to, well, pretty much everything. So take a look at your own work, whatever your field is. What are the recurring problems you face? And what are the proven, reusable solutions that are just waiting for a name?